So from this log right here, you can see that our repository will be emitting this Kotlin flow on dispatcher main, which is the same dispatcher as the view model is collecting on, right? Unless we explicitly declare this operator called flowOn in our repository function, which actually emits these values into the flow. So be sure to watch this video until the end, because this topic is really important, especially if you are working with Kotlin Flows. Okay, so here I have prepared one demo project to demonstrate and show you how Kotlin Flow actually works when it comes to these dispatchers, right? So we have a simple repository that has one function which emits some kind of a flow, right? So it will emit only a couple of those values and then it will stop. After this flow builder, we are calling a flowOn function to specify on which dispatcher this actual flow will flow on, right? Down below we have the view model, so we are initializing this repository. We are calling that flow function that produces the flow. And then in this init block, we are basically triggering this collection after the view model is initialized. And this is for the demonstration purpose to see where our collector and our emitter will flow on which dispatcher. Also, in our composable function, we have the launched effect block, which is also using that same flow and collecting that flow, but in this case in the composable scope. So in both of these coroutine scopes, so the vmodel scope and the scope of the launched effect block, we are printing the actual dispatcher of that current coroutine, right? So now let's launch this application and see what kind of a result we are going to get. So after we launch this application, we're gonna emit here a couple of values, so doesn't matter. Let's just go all the way to the top. And here the first thing that you're going to notice is this println that says view model is collecting on the dispatcher main, right? Because by default, the view model scope will always run on that main dispatcher. And that's why here we are printing that same dispatcher in the vmodel scope. However, in the repository, we're actually emitting on a different kind of a dispatcher, and that's all because of this flowOn operator that we have specified, right? And then in the UI, in our composable screen, let me just scroll down below. So here it is. So UI is collecting on an Android UI dispatcher, which is practically the same as a main dispatcher. It's only triggered in the composable scope, okay? And with that repository that is emitting for this second collector, we are also using that same dispatcher IO. But what will happen if we try to remove this flowOn operator from our flow builder right here? Let's test it out. I'm going to open up the Locket again, and we're going to track that one more time. So we're emitting some values, and then we can see that the view model is collecting on dispatcher main, and now the repository will start emitting on that same dispatcher, right? So what can we conclude from this example right here? Well, we can conclude one thing, that the actual producer is inheriting a dispatcher from its collector, right? Because its collector is actually running in that same coroutine scope on which the producer actually depends on. And that's why the producer will actually inherit that same dispatcher. The same goes with that other different use case in our composable function. So UI is collecting on Android UI dispatcher, and this repository is now collecting or actually emitting on that same dispatcher, because in this case that cold flow repository cold flow has inherited its dispatcher from this launched effect block. And this basically tells you that it's always a good idea to call a flowOn operator on your actual repository functions, so that this operation right here can flow on a different kind of a dispatcher, especially if you have some kind of heavy computations or expensive operations, right? So you want to make sure that you are always using the appropriate dispatcher in your repository and not the one that you are inheriting from the view model or the composable screen itself, okay? Now, the second approach would be to remove this flowOn from our repository, which is not a good idea, and use this view model dispatcher that we explicitly pass to our vmodel scope, right? So in that case, our repository function will inherit this IO dispatcher. So now if we open up the logcat, you will notice that the Vimol is actually collecting on that IO dispatcher, and the repository will also emit on that same dispatcher, because we have explicitly specified that the Vimol scope will launch on this dispatcher IO, okay? However, this launched effect block that triggers a different collector, it will use that default one, which is Android UI dispatcher, which would mean that we need to launch here a new coroutine and explicitly specify that dispatcher IO as well. However, it's much easier to just use that flow off operator or flow on operator and make sure that this flow will always flow on that same dispatcher that we have specified right here. And we're not gonna reuse that dispatcher from the actual collector block, okay? Now, in most cases, if you're working with, let's say, a room database, I assume that the room database already handles this internally, so they do use dispatcher IO for a database operation, and you probably don't need to wrap your actual code or use this flow on at all. However, if you're building your own call flows, then this is the way to go. And that's it. So let me know your thoughts in the comment section down below if you knew this kind of a trick with Kotlin coroutines and flow. And of course, don't forget to leave a like to this video, but only if you find it helpful. Thank you for watching.